What's up, Calc gang? We got some differential equations here. Okay, so it wants us to make a phase line for this and classify all the equilibrium points. So looking at this, it looks like we're gonna have 3 equilibrium points. I'd say so. We're gonna have 1 at 0, we're gonna have 1 at 1, and we're gonna have 1 at 2. So let's go ahead and draw that. So on this graph here, you're gonna have y on this side, and then y prime, which is a function of y on this axis. And basically, this is this. So just think of this like you're plotting a normal graph. So of course, we can see that if y is equal to 0, this whole thing is going to be equal to 0. If y is equal to 1, it's going to be equal to, 0, and this is going to be equal to 0. Okay, so now we have to figure out how does this graph look like, What is it like, how does it behave as it goes into these points? So let's do that. Okay, so one thing I like to do is first you want to see what's the highest exponent. So if you multiply this out, if you factored it out, you have y, y, and y. So it'd just be a positive y to the third. And we know that this is going to look like a function that looks something like that, right? So that means that it's going to come in from down here and it's going to leave up here. Okay, great. Yeah, that's one thing we know. Let's see. When I end up with these things, I like to, I'm not too sure basically what to do. But as it goes into this point here, as it approaches, you can see it's going to go from when it's less, it's going to be less than 1. So when it's less than 1, this is going to be a negative number. But then this is also going to be a negative number, so it's going to be positive. So you can tell up here it's going to be positive. Another thing you can do is you can just plug in 0.5 and see if it's positive or negative. And because it doesn't cross 0 in between these 2 points, this whole part's going to be positive. Let's see what happens here. Well, if it's 2 or gets a 1.5, this is positive. This will be negative, and this will be positive, so it's going to be negative. And then we know it's going to go up like this. Okay, so we have our line drawn out. Let's go ahead and do the thing. Okay, so let's find our equilibrium points. Let's see, we have them, but we need to classify them. Are they stable, are they unstable, or are they semi-stable? Okay, so to do that, we see, is this above or below? So this is below, so our line is going to be pointing this way because it's negative, right? But then when it comes here, it's positive, so it's going to be pointing in the positive direction. Then here, it's negative, it's going to be pointing negative. And then here it's positive again, it's going to be pointing positive. Okay, so let's classify these. So this one, the first one we're looking at, the arrows are pointing out. That means that it's unstable. What I like to think is if it looks like this, the graph is going to, here's our equilibrium line, it's going to go away from like that. That means it's going to be unstable. And that means it's an open circle because the points are pointing away. But then this one, you got the lines pointing inward towards it. And that means that it's going to look something like this, where it's going fast and then it's going to, converge. It's going to asymptotally, I don't think I used that word correctly, but it's going to, converge to this point. So this is a stable point. And this is unstable again because they're pointing out. So you can see that we have an unstable equilibrium point at y is equal to 0 and 2, and stable at y is equal to 1. Yep. That's how you do these problems. So yeah, stick around for some more if you're having trouble with them, and yeah, see you next time. Good luck, Calc gang.